So we'll start the programming statement for a Inorder Traversal. So given the root of a binary tree, we have to return the Inorder Traversal of its nodes value. The Inorder Traversal means visiting the nodes in the order, right, as given in this revision part. So Inorder is defined as we have to visit the left node first, then root, and then the right. So if you see, this is a problem statement for the Leet code 94. So this is the example given. So we'll try to solve this example in terms of Inorder. So before going to the Inorder part, right, we'll have a quick revision of what actually the traversal we have, right? So there are three traversal methodology. One is the pre-order, then the in-order, and then the post-order. So what does it pre-order mean? So it is similar that we have to visit root first, left, and then the right. So similarly for the post-order, we have to visit the left node first, then right node, then the root node. So first of all, we start with the pre-order here. So we'll start with the root node. We'll traverse like this. So this is the first traversal. So if you see, it is the one-time traversal we are doing, correct? So if you see 1, so that means in pre-order we have already traversed, right? 1, 2, 3, correct? So 4 is also new. 2 we already visited. Right now we are in the 4. So we'll put it here 4. Then again traverse it back. Right, 2 already visited. 1 we also visited, right? Then 5 is the new one which we actually visited right now. So this is 5. Fine. Now, if you see in the pre-order, we actually visited one time for each and every node, correct? Now, what will be the case in the in-order right here? So, if you see in the in-order part, I can take this example here, right? So, 1 visited one time, correct? Then 2, then 3, correct, is visited time. Now, if I put it here, right, a kind of a dummy leaf node of the child node, how it works. Now in the second case, right, it will traverse like this. So 3 already traversed 1, then 2. So this is the second time we are visiting. So that means we visited the node 3 2 times here. 3. Now again we traverse back, right? Then we come back to 2. Now node number 2, right, we traverse twice, so that's why it will be 2, right? Then again we will go for node number 4. If you see, right now we are traversing second time, so that's why here node number 4 we added. So that means each and every node is visited twice, correct? Now we go back. Now 2 is again already done, right? We already visited twice. Now 1. So 1 node number is visited again twice. So that's why we added here. And then finally, if you see, right, so we visited first time, then second time. So that means we are visiting twice. So node 5 will be added in the pre-order. Now accordingly again we actually complete the loop. Now what will be the case in the post order? So we'll just rub it out, right, whatever I have shown, so for the better understanding. So if you see, so I'll just put, maybe I'll just rub it out freshly. So here, what we are doing, so as I told, here, right, we will put a dummy leaf node, which is actually the node here, correct? we already took as a null. So we have to see that each and every node will be visited thrice. So we started with 1, 2, 3, correct? 3 twice, then 3 node thrice. So 3 will be added here. Now node number 2 twice, we traverse it like that. Node is the second time we are visiting, node number 4. Then is the again thrice. So we will add 4 here. Correct? Now we will go back. So again node number 2, right? So it's already one time we visited, second time, and this is the third time. So we added 2 here. Then again node number 1 we visit twice right now, 1 and 2. Now we again come back to node number 5. Alright, so if you see here 5 we visited one time, second time, this is the third time we are going to visit here. So 5 will be added here. And finally, if we traverse back to 1 again, the same position of the node, so it will be visited right now 1, 2 and 3 times. So if you see this, traversal for the number of times is one of the intuitive method to find the pre-order, in-order or post-order, although we know these protocols or rules irrespective of the tree traversal. So now coming back to the question, right, since we are concentrating on that in-order traversal, right, which is actually defined by left first, then root and right. So we'll code it first. Now before coding, right, if we go for the time complexity, so the time complexity of the in-order tree traversal is O to the n, and the space complexity is O to the height. H means height here. So here height is 1, 2 and 3. Okay, so we'll code it first. So we defined a class node here. We initialize or making a constructor where we'll pass the value here, where left and right are the left node child and right is the right node child. So we define the pre-order function here. Here we define that if the root is not, if the root is not there, we return directly nothing. Nothing is there. Correct? And if the traversal root is there, right, we return the in-order function with given root dot let plus root dot value. Obviously we have to pass the value, and the in-order traversal with the root dot right value. Now we execute this one of the taking and one example here, right, where we define the different nodes, right, 1, 2 and 3, and we deploy the nodes, node 1 as a root. In the right side we put as a root of the right side, we put a 2 on the right side, and again the left side, right, we put a tree node number 3. Now we'll run this. So if you see, right, it's already given, right, so we are getting a expected output as 132 as a in-order traversal function. So thanks for watching this video. I think the video is very clear to everyone. Thank you very much.